Good morning, everyone, and once again, welcome to yet another informative session on process safety management brought to you exclusively by the British Safety Council India. I'm Melroy Alfonso, the India Events Manager at the British Safety Council. So, in today's webinar, we will learn about asset integrity life cycle management strategy that will talk about the importance of devising state-of-the-art solutions to overcome any challenges one can face while dealing with critical processes and handling hazardous toxic materials. And to throw light on this topic, we have none other than the head of process safety management at the British Safety Council India, Mr. Amresh Deshmukh, who has an impressive career spanning over 25 years and whose ability to navigate human dynamics in unprecedented environments has been a key factor in driving successful outcomes. But before we begin, there are a few housekeeping rules that I would like to tell all of you. Attendees are requested to post their questions in the Zoom Q&A box. Do not use the chat function, only use the Q&A function to post in all your questions at any time. At the end of this webinar, please ensure to fill a short survey form that will allow us to improve the quality of content with the help of your valuable feedback. And now, without taking any more time, I would like to welcome Amresh to take over this session. Amresh, all over to you.
Welcome to all the people who have participated in the webinar. I hope I'm very clear on my audio, audio. See, the main agenda for taking this session is to tell you that the asset integrity strategy has to be slightly different from your maintenance strategy that you already have in place. Now, before I share this webinar, I would like to tell you that British Safety Council has developed a 14-element framework for process safety management, which has taken care of various aspects that have been highlighted in OSHA PSM, the CCPS 20-element framework, which is risk-based, and also the 14-element framework, which was stated by the Energy Institute. Our framework is being developed closely working with UK HSC, and a lot of learnings are based out of the 34 major accidents that the world has foreseen in the space of process safety. And these learnings have resulted in creation of a variety of guidelines around various elements of process safety. And we would be more than happy to share with you whatever information or knowledge we have around this space. Asset integrity, for that matter, is a two-day event. It's a two-day training program or a workshop which you can undergo to get benefited the most. But I think in this short webinar of 30 minutes, I'm trying to establish a simple strategy that you can adopt before you change your existing maintenance practices to align your asset integrity program to the requirements of process safety management. So I'm sharing my presentation without wasting more time. Hope my slides are visible to all of you. So moving forward, as you can see, our framework comprises of 14 elements, and currently we are talking about the fifth module, that is asset integrity management. As you can see, it's the outcome of the hazard identification and risk assessment exercise that we do, and it sits along with plant and process design, operational parameters, and obviously the asset integrity management program that you have. The objective of doing it this way is your entire asset integrity program has to be risk based. The maintenance plans that you devise within your asset integrity program, they have to be suitable to contain the hazardous material in the primary containments. And while doing that, you have to be absolutely sure that the primary containment vessel that you have devised for containing the hazardous material, it is based on the outcome of the risk assessment and the basis of safety that you have provided before getting into the asset integrity program. There are other elements and there are other connections with the asset integrity program, like your engagement with the contractors, your engagement with other aspects of change management or issues related to competence management. But we won't be talking about that today. Our prime focus would be on deriving a strategy for your asset integrity management program. So as you can see, every program would have a minimum set of ingredients that are required for making the program successful. And the reference for this you can very well find within the process safety management framework that British Safety Council has developed closely working with Ian Travers. And this document is available online. You can always write back to us, or you can seek input from us in terms of getting this document. You can get it as the webinar is over. So the minimum ingredients for this asset integrity program typically would mean of having a basic risk-based asset management program in place. When I say risk-based asset management program in place, I want you to understand that whatever hazard identification and risk assessment exercises you do, especially while you're handling your critical assets, or when you're handling hazardous material at site, you have to be absolutely sure that any loss of primary containment that you may have to any of the primary elements that are there in the asset integrity management system would result in events which are unacceptable, events that can have catastrophic impact on site. So while you are doing that, the primary requirement for each of those primary elements is to be completely aware about the failure modes that you may have. Any primary containment device that you have will have a predefined set of failure modes, and when you address those failure modes, you would be in a better position to manage the site assets within the predefined sets and standards that are available. You can refer to the standards and codes which are shared by the OEM, or you may refer to the international codes available, and you can devise your own asset integrity management guideline, which can help you or provide you necessary guidance while maintaining a primary asset. While you do this, you also need to maintain a set of assets within the asset register that you have. This asset register is containing a list of critical assets and non-critical assets. Now, when you say that you have both the variety of assets within your organization, your primary focus for asset integrity would be to focus on the critical assets, because when you're maintaining the critical assets and managing the containment of the hazardous material within the critical assets, this register would become quite important. Now, the other important thing is, apart from the criticality list that you have, you should also be very well clear about the safety critical plans that you have. This has to be done using hazard maps within your facility, and you should know which are the units within your existing facility which are safety critical. Uh, this is necessary to mention here. Don't leave it to the last moment to conduct your functional testing. It's necessary that you keep on doing factory acceptance tests and the site acceptance tests for all the safety critical assets, not leaving it to the last commissioning checks which are followed after your site PSSR. You have to do intermittent checks as well as you maintain your asset integrity program. Ensure that you have a list of critical spares. You have the safe isolation methods for the critical spares, for the critical assets defined well within time. Don't limit your strategy only to breakdown maintenance or preventive maintenance. Use predictive maintenance strategies like condition monitoring at various critical locations of your plants, so that you know that if there's any deterioration or if there are failure modes that are creeping in, if there is degradation, you would be well in position to handle those degradations well in time before it fails. The most important facet of your program would also be to ensure that the competence of the people who are handling this program is taken care of early on. Don't wait for the program to mature and then address this competence part. Competence would have two aspects. One is technical competence, and second is system competence. So on the technical side, one has to ensure that all the job descriptions are having the necessary inputs inbuilt into the job description, and the competence is validated from time to time, so that if there are any new skills that are to be added to the JD, they are being revised in a regular timely basis. One more challenge that most of us are facing nowadays is we are contracting out a lot of inspection and maintenance. Now, though we are able to push on this activity to an external vendor, this also makes it necessary that we also equip the vendor adequately and help him understand the practices that we have around process safety management. So if you are contracting out work, remember one thing: you cannot contract your responsibility. You can contract the work, So when the responsibility sits with you, it's necessary that you understand your part of the work that he does. So it's again equally important that when you're contracting out this work, the competence of the external vendor who is being roped in for handling your critical assets is maintained at all times. There's no leeway given to him just on the basis of cost, so for him to perform some secondary or tertiary work at a lower level of acceptance, or having poor quality. While you do this, you also need to establish adequate performance and data intelligence measures. You can develop your own KPIs, and those KPIs can be developed function wise, and especially for the project teams or the maintenance teams, or even for the contract manpower. More information about this can be found in the framework, and you can very well get in touch with our marketing team. They'll be happy to share the entire framework with you. So coming back to the process safety management program, now the basic objective of this for this asset management program is to ensure that the performance of the plant, equipment, and sensors is within the acceptable levels of performance. Now this is required to maintain the basis of safety at all times, because we want to ensure that the hazardous substance is present within the primary containment. There's no point within the life cycle of the unit that you're operating that the hazardous substance comes out of the primary containment. Now, the second outcome while we are doing this is to monitor regularly the maintenance program and collect evidence. Now, the collection of evidence or intelligence is a function of doing predictive maintenance for all your critical assets. You can do vibration monitoring, you can do temperature monitoring, you can always monitor various variables within the process equipment to ensure that the integrity of the primary containment is intact. Now, who doesn't know Bhopal? Actually, this is the cradle of process safety management, and this is where the entire journey of process safety management begin. Now, on that unfortunate day, we had around 5 lakh people exposed to methyl isocyanate, and the official number of people who where a part of the death toll was 3,800, and more than 20,000 people were affected by this event. Now, if you really go to the details of the MIC event, we find that this event was largely because of backflow of water into a MIC tank. Now, while this happened, everybody was very well aware that water interacts or reacts violently with MIC, and there were adequate engineering measures in place. Had they been functioning, this could have been avoided. But over a period of time, the pipelines which were carrying this material were in poor condition. Several vent gas scrubbers which were supposed to be in operation, they were put out of operation. The valves were poorly maintained, and the steam boiler, which is necessary to maintain the pipes clean, was kept out of service. So, as a result of so many failures on the maintenance program, which we do not realize that what roles these pipelines would play, what roles these walls would play. We actually underplay the overall impact this can have when something goes wrong on the process safety side. So, in process safety, we use this line: one incident is too many. So it's necessary for us to prevent that one incident so that we can operate safely. Now, taking another case study, this is the Refinet Tower, which actually refers to the Texas City refinery investigation. Now, here you had level measurement, which was supposed to monitor the level at around 2.5 meters, and there was a high level sensor which was set at 3.5 meters, and the Refinet Tower reading was taken to the control room as well. So while you are monitoring this level of Refinet Tower, which was handling hydrocarbons, the objective of this tower was to heat the hydrocarbon, and beyond a point, you are not supposed to do any addition to the Refinet Tower. You also had a blow down drum below after the Refinet Tower, which was supposed to take care of any excess addition that happens to this Refinet Tower. But the problem was the level sensor, which was supposed to monitor the high level, was malfunctioning. The level reading which was coming to the control room, that was faulty. It was at 2.4. This was largely because of the discrepancy that has crept in the maintenance program while you were maintaining this functionality of monitoring the level and monitoring the high level. Now, when you get into the details or the documents which have been released by AICHE, these are the lacunas that they have found when they looked at the basic failures that have happened while this event took place. They clearly established that the level indicator was incorrectly calibrated and it was not displaying the right reading. The high level alarm was not functional and it did not even give a sound when this event happened. The side glass was dirty and that prevented the operator to see through to do a manual verification for the refinite level. The manual vent walls were also allowed to vent vapor from the refinite splitter tower. This was not functional during the startup time or during the testing. And the high level alarm of the blowdown drum, this is something which is present on the downstream of the refinite tower, was also non-functional. Now, what does this mean? These are a series of errors that have happened around the same refinite tower, and this could have been prevented. Now, can you imagine someone adding 15 times the volume of hydrocarbon into one refinite tower? The high level was set at 3.5, and according to various reports that we have, the refinite tower was filled to 48 meters high. This happened because there was no control, there was no secondary mechanism which could prevent the addition of refinite after a predefined period of time. You can very well devise time-based addition mechanisms for hazardous material as well. There are other ways to overcome this problem other than the ones that have been specified here. So it's necessary that you have a healthy asset integrity or mechanical integrity program. The observations taken here are from iChemy, and you could very well download it from the websites that you can refer to. Now, let's look at another primary thing that each one of us should be aware of. As you can see here, we have categorized three squares. The first square talks about process equipment. These are equipments which have adverse impact on plant or processes, but do not have any safety impact as such. The second stage of the equipments are, if these equipments fail, they will have an adverse impact on the containment, that the primary containment is going to get affected. And though you may have passive protection, but the impact of safety critical equipments in this space would actually result into it may not be a catastrophic failure, but it would be like a loss of a primary containment. And third thing is the safety device. If this fail, then automatic shutdown and emergency system may not be available or may not function. So that this would be the last mitigative layer that you have. If this mitigative layer doesn't work properly, then you are into a catastrophic event which cannot be prevented. So just for a minute, I'm trying to put an exercise to all of you. These are four devices that I've put here, and there's a pressure gauge, there's a transfer pump, there's a steam pipeline, and a pressure relief valve. On your notebooks, what you try to do is you categorize each of this in any of these three categories. So I'll give you 30 seconds for that, and then we'll look at the answers. Okay, so I'm going to the next slide. So if you look at the pressure relief valve, which is a safety device, its sole function is to release excess pressure from the boiler should the pressure rise to beyond a safe minimum or safe maximum pressure. If it failed to operate when required, it can have catastrophic consequences. People in the boiler area or around the plant might get affected. The next is a pressure gauge. The function of this pressure gauge is to show internal pressure of the system. This may have a process function in controlling normal conditions as well, but it can be used to show when the pressure has risen beyond the acceptable safety limits which are specified. So it can be classified both as safety critical, and it can also be classified as process equipment. Now, if you look at the pump and the steam pipeline, you are not given any information on their location or context, so they can be classified as process equipment. However, this could change if, for instance, the pipe is used to convey high pressure steam and was located in an area where people work or pass by. Even if you have to classify the pump also as critical, that can happen if this pump is going to transfer some hazardous material from point A to point B. So the classification of these three units, like this is a very important thing for all of us, because we all would go through various risk assessments, and we may classify something as non-critical or something as critical based on the service that it is being used to, based on the impact it can have, and based on various other factors that may come up for discussion during those risk assessments. So use your judgment wisely. Also ensure that you don't land up being over conservative. Don't make your maintenance program look like as your asset integrity program. Asset integrity program is to prevent catastrophic failures. When I say catastrophic failures, failures which will lead you out of business. Your existence is at threat. That's what actually an asset integrity failure might lead to. So a process safety management program actually primarily focuses on preventing catastrophic failure. Generally, what happens, people actually look at all the failures that are happening in a plant and put those failures under process safety management. You may have process safety events, you may have process safety incidents. These things will also happen when you have a process safety management program. But please understand, the first goal of each one of us who actually is a part of process safety management is to ensure that there are no events that lead to impact on people and impact of environment which is irreversible. If there's someone who gets hurt, we don't want other events as well. And the goal zero, which is being used so often by so many EHS professionals, is there to stay for a long time to come. And you stay on that. I'm not saying you to deviate from that path, but my sincere request to all of you is to keep your process safety management program separate to your EHS program. Now, as you look at both these programs, one is the process safety program and second one is your asset management program. The basic objective of the asset management program is to ensure that your assets are optimally maintained and you do not have surprises in terms of breakdowns when you're managing your assets. Now, if you have to marry that with the goal of process safety management program, typically the goal of a process safety management program is to ensure that we do not have loss of containment of any hazardous material that can have catastrophic impact on people or environment. Now, if this has to be married, this has to be done in a way where when you're managing your assets, you do those risk assessments in a way where the primary containment or the loss of primary containment is prevented. Now, if you approach this planning and strategy for asset integrity by clearly focusing on the high risk events that may happen at some of the critical plants that you have in your facility. When you do your hazard identification and the risk assessment, you be absolutely sure about those scenarios which may have catastrophic outcomes to your units. It may also lead to impact on the society apart from the people who are working within the facility. So whenever you come across such events, you are actually preparing the asset integrity program in a way where you are also managing the outcome of your process safety management program. The outcome of process safety management program would be to prevent a loss of containment, and the objective of asset integrity program would be to prevent unnecessary outages. So both these things can be achieved together when you are having a strategy which actually is risk based and not the typical maintenance strategy that we adopt for all equipments. So this is one input. This is an important graph that I'm trying to share with all of you. This could be quite handy for all of you if you really look at this. Here I'm trying to share with you something which is quite important. Initially, what we do, we actually try identifying the hazards that we have in a particular unit. While doing that, we also try to put in practices all three strategies are put to use. The breakdown maintenance strategy is used, the preventive maintenance strategy used, the predictive strategy also is used. You do a lot of condition monitoring also to a variety of your assets. And based on the hazards involved, there are two things that you keep on doing. One is you try to look for the likelihood of failure, which is called as LOF. And the second thing you try to do is the consequence of failure. Based on this consequence and likelihood, you arrive at a risk number. Now, this risk number is going to define what strategy you're going to adopt for a particular equipment. Are you going to work on the likelihood part of this equipment, or are you going to look at the consequence part of this equipment? Now, whenever you work on the likelihood, you're trying to work in the preventive zone. When I say the preventive zone, I'm trying to look at the basic design of my equipment. I'm trying to look at the basic process control system or the DCS system that I have. I'm looking at the alarm management strategy that I have, or I'm looking at the safety instrumented systems that I have. So the prime focus for each one of us who is doing process safety management is to prevent an event. And when someone is trying to prevent an event, he definitely has to focus on uh, increasing, like I would say, you have to ensure that two events are separated by a longer period of time. That would mean that I would have a lower frequency of occurrence. If I keep on reducing the frequency, I'm working towards adding value to the preventive landscape of process safety management program. However, if I'm trying to focus on the outcomes or the consequences, the areas that I'm really looking at is on the mitigation side. I look at the active protection layers, your pressure relief valves, the PSV system that you have, or if you are looking at the blast walls or the blast zones at the passive protection layer, and the last layer is the emergency protection layer. So when you focus on reducing the consequence, you are anticipating that the event has happened and you want to mitigate it. When you're focusing on the likelihood, you're anticipating that I am doing everything possible to prevent that event from happening. Your PSM program needs to have both these components. And as an outcome of devising the preventive and mitigative strategy, you also end up devising your integrity management strategy. What does that mean? It would mean that I'm pretty sure what is it that I'm going to inspect. I'm sure when is it that I'm going to inspect. How am I going to inspect the same thing? The extent of inspection, is it limited? Is it limited only to a few proof testing cycles, or would it mean that I need to continuously inspect this? Now, this extent of inspection would also mean that I may change my predictive maintenance strategy. I may try monitoring some of the variables like vibration or temperature on a continual basis. The reason of doing this would be I am actually monitoring the various failure modes, the various degradations that might take place. And if I'm having a good hold on the various degradation modes or the failures, I would have information well within time before the primary containment fails to ensure that I devise the preventive maintenance program for a particular equipment, or I modify my inspection plan in such a way that this primary containment doesn't fail, or I would ensure that it's actually tested well within time before the failure happens, and that way I'm strengthening the preventive mechanism for my asset integrity program, and at the same time I'm further improving my asset integrity strategy also. Okay, now coming back to the inspection and maintenance methods and controls that we can adapt. Now, as you see here, uh, as an outcome of the initial critical equipment management program, you have already identified all the assets. You have an asset register and you have tagged them appropriately in the field. What one needs to do is, based on the criticality, there has to be a criteria which clearly says that for critical equipments, there is no leeway. There's no program on site which will give me some leeway to avoid that maintenance and move on with my regular manufacturing practice. I have to do the maintenance for critical assets on time. There's no exception to that. So if I have to look at my maintenance program, what are the things that I would be looking at? I will first try to see what are the probable ways in which my asset can fail. The failure modes for each asset would be known. At the very beginning of the program, I will see what is the expected life cycle for a particular asset. And if I know that the first signs of failure for a particular asset, uh, if it's a case of flanges or gaskets, if it's a leak, or if it's vibration in case of rotating equipment, or it could be a total loss of function or containment. We have also come across events where the pipe had some cracks, some minor cracks, and those cracks actually evolved into full-blown failures for the pipeline. So there are signs that you may get or capture from the field, either from your visual inspection program or from your predictive maintenance program, which can be inbuilt into your preventive maintenance strategy. Now, while you're doing that, there are some guidance. There's some guidance that you get from the OEM as well, and the OEM also helps you with some preventive maintenance plan that he has with him, and you can use the recommendations given by the OEM. But do not leave to that. What you should further do is you also look at your own experience. Now, if a particular equipment has been failing more often than what the OEM recommends, then your maintenance plan should change. You should not stick with the same plan. Breakdown maintenance as a strategy is a no starter for process safety management. You can't allow breakdown maintenance as your strategy for process safety events. So this can be a strategy, and overall, if you look at your maintenance program as such, you can have breakdown maintenance for some of the process safety equipments, but not for the safety critical equipments. Now, when you are contracting out your inspections or maintenance, which is quite often a case nowadays, ensure that it's been given to specialists or experts who are good at handling those primary equipments. And if you happen to outsource it to someone who is not known to you, you ensure that you have adequate competence validation mechanisms in place before you allow that individual to perform those tasks on your site. It has to be under your supervision, because you would be able to outsource the tasks, but you won't be able to outsource the responsibility. It still lies with you. While doing inspection, also take a few other things into consideration. See to it that the aging of the assets is thought of. If there are assets which are aging, you also need to have a replacement cycle in place. If you are going to put it back to use even after the useful life, ensure that necessary predictive maintenance is taken care of. You have those outcomes that if it's been put to use, it's been done post necessary testing and validation from the quality front as well. The quality has to approve that this equipment is good to use even after its lifetime. And definitely ensure that you have a fixed predefined cutoff time as well. Don't use it too far, because once, if you look at the bathtub curve, beyond a particular point in time of the age, you'll find that all those equipments which were bought together would start failing together. So it's necessary that you have a predefined cutoff for each of your critical assets. Now, this is something important which I would like to share with you. Now, if you look at this optimum performance of a particular equipment. Now, if I just look at the first box where I am trying to highlight the optimum performance, just to start with, when I'm putting the equipment to use, you'll find that typically in a theoretical world, we assume that over a period of time before it approaches its first maintenance, the deterioration would follow this particular curve. This is pretty linear. If you really look at it, it's predefined. And when I do my preventive maintenance, it again goes back to normal, and this keeps on happening. Like, I'm just giving this as a 5-year interval period. Assume that it's a 5-year interval period, and our assumption is theoretically this is how every system should perform. But in the real world, it is slightly different. If you look at this, you have 5 different graphs here. The first graph depicts the same thing that I shown in the previous graph, so there's no change there. But on the second graph, as you can see, there is sudden deterioration midway. And this deterioration is well within the acceptable performance limit. It has not gone below the minimum performance level, but then it is performing substandard. So this is a data point that you have, the deterioration in the performance of a particular variable. And when you redo the preventive maintenance during the second interval, you are restoring it back to normal. Now, if you look at the third cycle, it is slightly different. You will have sudden failure. the sudden failure is so bad that it actually reaches the minimum performance level, and you would be operating for quite some time before your maintenance comes in, before your preventive maintenance cycle kicks in. So now you're operating under the minimum performance conditions for quite some time. So if you look at cycle number 2 or cycle number 3, there is some scope for you to modify your maintenance program for this type of equipments. You can relook at the frequency at which you are doing preventive maintenance. Now, this is in the reference of the critical assets. I'm not referring to this particular graph with respect to the other assets as such, which are not a part of your critical equipment list. And the most dangerous of it is, if you really look at this one, the fourth cycle, where the performance has gone down below the minimum performance level, and you are actually in a state where this equipment should not be in operation. So for all your critical assets, wherever you come across this situation where you're operating on a suboptimal level, where you're not even meeting the minimum expectations that are meant for the equipment to perform, you are actually you're in the red zone. Your equipment or the reliability of that equipment for that particular operation is not up to the mark, and that's where you're in the risk of zone. The event may or may not happen depending on few other factors which are not limited to this equipment. But if I have to be very uh, upright to the principles of asset integrity management, I should not have any equipment in my plant which is operating suboptimally. At any given point in time, all the assets which are a part of the asset integrity program or the safety critical equipments, they can just stay within this band from the optimum performance level to the minimum performance level. Anything that goes below that would call for immediate maintenance or immediate shutdown, which can actually bring back the equipment back to the safe state and relook at the maintenance or preventive maintenance program that you have for that particular asset. Now, these are a few other things that one needs to be mindful of. You be absolutely sure that the place of work where the maintenance is being performed is safely and securely taken care of. There should not be a case where if this guy is exposed to some process safety condition, he's not in a position to escape. It should not be a case where he's working in an unsafe environment. If there's something that can go wrong, and if this guy lands himself in a zone of harm, you should provide him with adequate opportunity to escape. Now, I have seen a lot of guys working on tankers of hazardous material without any escape possible for them from that. The only thing that they can do is they can jump from a 4 meter or 5 meter height. Now, how do you handle this situation? There's no escape available. So I think the best way for all such operations, and mind it that the tanker operations, or if you are handling hazardous material, you would be handling that hazardous material multiple times in a day. That would mean that thousands of operation in a year. And if you have an unfortunate event while filling or unloading the tanker, then I think there's no escape for the guy who's there on the top of the tanker. Now, ensure that you have adequate working platforms, and the moment for any maintenance work that is being carried out, you have provided those guys with adequate support in terms of the tools and tackles that they use for performing such tasks. Now, this is one more important thing. Now, this is applicable not only to the major turnovers that you undertake, or to the major modifications that you do. This is applicable for every startup and shutdown. It's necessary that you perform recommissioning checks for the integrity of all your primary containments. If you come across a case where the primary equipment was not tested before being put back to operation, then you are in clear deviation to the basic principles of process safety management, where the recommissioning checks are to be performed before you put the equipment back to operation. It's the responsibility of the functional experts, be it mechanical, electrical, or instrumentation, to certify the correctness of operation for each of those critical equipments. It could be electrical equipment, it could be instrumentation device, or it could be a mechanical equipment. In either of these cases, before being put back to operation, someone has to specify that it is safe to use it. Now, one more thing which people generally miss on is they do not consider the structures, the pipelines, the pipe racks, the pipe bridges, or the structural facilities that are there in the plant, which contain or which are which are acting as supports to the hazardous equipment that are put to use. It's necessary that we also do structural audits for the entire facility, and we assure ourselves that the structural strength is optimum, or it's sufficient enough for you to use that facility at least till the next operational cycle. Now remember, this thing is very important because you do not do structural audits every year. You do it at a frequency of 3 years or 5 years, and based on the certification that the structural engineer does, you're going to use it for 3 years. Even if you come across scenarios where you identify some failures, you won't be calling the structural engineer immediately to address that issue. You'll generally do it if it comes on the predefined cycle of verifying the structural stability. So it's necessary for all of you to keep a tab on the structures as well and have some checklists in place which will assure you that the structural strength is there. Wherever you're handling hazardous material, you'll be able to ensure that the primary containment is not lost. There have been events, as you can see, for this power plant where the belt collapsed during shutdown, and that belt, the collapsed belt actually felt on a building which was structurally stable, and it damaged that building as well. And it's necessary that we do not land up into issues where the unsafe structures end up damaging the safe structures, and then you have a domino in place. So these are the key attributes that one should really focus on when he's having a very healthy asset integrity program. You can have a risk-based strategy. You should be aware of all the degradation modes. You should have the asset register and the equipment identification for each of the critical assets. You can also try to ensure that you have a very well-defined critical spare management program. The safe isolation methods for all the critical assets are well-defined. You should do the recommissioning checks or validation checks well in time. Don't wait for the PSSR. You do it as and when the equipment is ready. Ensure that all the condition monitoring devices are working all the time, because this is something that can help you detect the various initial failure modes and help you ensure that you act well within the major failure that can have happen to any of your critical assets. Ensure that all the vital utilities are following the Raga practice. You should have adequate backup for each of the utilities which are being used in the critical process safety units. The primary structural support should be there in place. The necessary audits have to be performed, and if there's any change there, if you are required to move out of a particular block, you should be able to take those bold decisions as and when required. Ensure that you follow all the legal compliances which are there in place, and I think anyhow this is generally been adopted by most of the units and you are there in legal compliance, but ensure that it doesn't become a tick box exercise. If there's something which is involving monitoring of your pressure equipments or measuring temperatures for hazardous materials that you're handling, ensure that you are not doing it just as a tick box exercise, and it's been taken care well for at least the safety critical assets that you have. So this is what I wanted to share with all of you, and you can ask any questions that you have. Over to you, Melroy.
Great. Thank you so much, Amresh, for that informative session. It was really very good, and it just put a lot of things into perspective. So before we dive into the questions that have come in from the audience, I would request the audience again, in case you have any questions, please use the Q&A box only to type in all your questions, and we will have Amresh answer all of them. So Amresh, the most obvious question that comes in is why asset integrity is crucial for process safety management.
See, like in a typical engineering world, we have been having our engineering or maintenance plans, and it's been there for too long. But as you see, we are downsizing now. We don't have the same type or same kind of manpower that we used to have for each function. Over the last 30 years or so, the people who are managing or maintaining it's going down. So it's necessary that you have a clear set of equipments where you identify the critical assets in a way. It could be 10% of the overall population or 20% of the overall population, but then you can clearly focus all your resources in a way where those 20% of the assets are initially taken care of. the basic strategy for this program would become like, I will ensure that at least this 20% of my assets are having adequate safeguards in place to ensure loss of containment. Now, for the remaining 80%, I may use my standard preventive maintenance strategy that I have. And in some cases, for 40% of the asset, I may even go for breakdown maintenance without doing a preventive maintenance as well. So that's why we are trying to ask our people to stay more focused on asset integrity, because if the critical assets are taken care of, you're absolutely sure that you don't have any catastrophic events in the units that you're operating in.
Right, rightly said. Thanks, Amrish. So there's another attendee that has asked this question. Can the risk-based program be defined based on hydrocarbon or toxic materials quantity held at a site? If yes, what is that limit?
Yeah, I think there are good many references available even within India. Post the styrene leak that we had at LG Polymer, there was a high part committee which actually had done the investigation, and it has clearly specified the quantum of hazardous material that you can store in facilities which are in close vicinity of the society. And they have given a number, the quantum of hazardous material that you can store. So if we make good use of our own investigations that we have, we'll be easily able to get an answer to some of these questions, which actually also helps us in separating our high risk items from the units that we are operating to another location where the risk is slightly lower or where it's manageable at least.
Yes. Yep. Thank you, Amrish, for answering that question. There is a very interesting question that has come up now. Okay. So it says that we already have a maintenance program at our site. So what's unique about having an asset management program? So it's like we already have something. So now what is the use or the benefits of this program?
Yeah, see, typically for every maintenance program, you have a strategy of deviation management also. Now, when I'm saying that you carve out your asset integrity program, the only objective here is you do not have any deviation management to your asset integrity program. That's point number one. The second important point is when you have asset integrity program in place, you can actually focus your resources more towards this set of equipments. So when you're focusing your resources towards this set of equipments, you won't have issues that either Bhopal experienced or what BP Texas experienced. So you know that you are absolutely in control of your critical assets. There's no point in time during your operations that you're not in control of your primary assets. That's the reason why we are trying to separate out this program from your basic maintenance program.
Okay. Yeah. Thanks, Amrish. So the next question comes up and it says that how do we decide the critical equipments based on the process?
Yeah, see, in fact, if you, as I discussed, I was referring to two critical concepts. One is what does it mean when you're reducing likelihood, and what does it mean when you're reducing consequence severity. So a lot of equipments which are part of the active protection layer or passive protection layer or emergency layer, they automatically become critical. They are safety critical. But when it comes to the preventive cycle, what you need to be really focused on, you have to identify if failure of this equipment, if it leads to loss of containment immediately, what are the various barriers that you have? If you go on to evaluate those barriers, and if you feel that those barriers are good enough for you to contain the loss of to prevent the loss of containment or to prevent the event from happening, then I think you are having the right kind of design for the critical assets that you are maintaining. But primarily be aware that you are monitoring the bare risk. Though you may have so many protections in place, some could be preventive, some could be mitigative, but your core focus should always be on the bare risk, because each of those layers may fail, and that could land you into those catastrophic events.
Correct. Very true. So, Amrish, the next question talks about technology. So they've asked, like, how is technology such as LOT or AI being utilized to enhance asset integrity in Indian industries specifically?
Yeah, see, we are in very early stages of use of technology, and anything and everything that we do would look beautiful early on. My simple suggestion to all the participants who would like to explore more technology is first get your house in order. Try to understand what do you know about your risk. Try to see to it that you're mapping your current states adequately. And if you are mapping those correctly, if you require some help from technology, like adding few more predictive maintenance cycle in place, or trying to automate some of those actions that individuals are taking, like using AI or AGI or using IoT for some of your maintenance of. But if you have to use technology, you first try to know the safe states for your various assets first. Try to clearly understand the assets and the hazards that you're handling first. And with that information in place, the information that you have or the knowledge that you have, if it is complete, then you can go on for adoption of any possible technology that is available in the market today.
Correct, correct. I think to answer this, I think having knowledge at the right source is very important in this stage, and then we can maybe apply all the other processes that fall into place. Correct, Amresh?
Correct. Yeah.
Yeah. Yeah. So the next question goes is as what key performance indicators should Indian companies track to measure the effectiveness of their asset integrity programs?
Yeah, if you, in fact, the most important thing that generally most of the guys do is uh, you are already monitoring the preventive maintenance cycles. You are monitoring what percentage of preventive maintenance cycles are being done regularly by the maintenance team. What is the breakdown data that you have with you? These are the things that have been monitored uh, since so many years. You may add a few other parameters also, like for example, if you have done the risk assessment studies for your critical assets, and if you have to do a revalidation of those assessment studies. Now, when you have this revalidation, it's at a frequency of 5 years. Within those 5 years, you have so many failures that could have happened to a similar class of equipment. So it's necessary that this data, this information that you have, actually of the experience that you had during the last 5 years, it's shared with the guys. There's an interface that the functionality of this unit, like if asset integrity program is running fine, there's a lot of information this element gives to other elements also. You have to share information with the HIRA team. You have to share information with the MOC team. There's information, there's interaction that you have with the competence team, the training team. There's interaction that you have with the contractors. So you can devise KPIs for each of these interactions that you have. So one example could be trainings that you are providing, the asset integrity trainings that you are providing to your contractors. How are you validating your contractors at work? You have a 5-step process for evaluating the contractors, but what is the role that the asset integrity team is playing to achieve the desired objective? Understand that the PSM program is not, it doesn't consist of 14 elements. There's only one objective of a PSM program, and that objective is to prevent loss of containment. This is one program. These are not 14 programs. So there's a lot of give and take that would happen within various functions when a healthy asset integrity program is running, and it would take time for you to stabilize this. Initially, you have to soak in a lot of information, try to make sense of that information, and then devise those KPIs.
Right. Yeah. So since we are talking already about contractors, there's a question come up that says how to deal with external vendors or contractors who are handling our critical assets.
Yeah, I think the entry gate is a very important place where you have to deal with the contractor. Do a competency mapping for the contractor who is handling your critical assets at the very beginning. Because if you like, the best way for handling this is for all your critical assets, if you feel that the competence is not there within your team to handle those critical assets, you engage the right type of contractors, and that engagement evaluation should qualify the contractor to manage your critical asset. If you come across a situation where the contractor is not competent and you don't have that competency in house, then it's necessary that you do not approve the contractor just for the sake of having one. put a elaborate competence plan in place, allow him to work on stuff which is non-critical in nature to start with, uh, develop the competency, and then test him on job, and then you can put the contractor to use.
Correct. Okay. So, Amrish, with regards to risk assessment, a lot of organizations do risk assessment through HIRA or EAIR registers. So, is that okay to start with, or is there anything else that they need to use to monitor and review all of these things?
See, the most important thing that one needs to know is what are the various failure modes for the critical assets that he's handling. If he's aware of the failure modes, and if he knows what are the various degradations that can take place. So before the equipment fails completely, there are various messages it gives you over a period of time of operation. So it's necessary that the risk assessment programs that one has, it takes care of the failure modes. The approach that BSc has been using for all this while is we use bow tie. It's a combination of a fault tree and event tree. And using bow tie can actually land you very close to the various failure modes. And while doing that, it will also allow you to add more barriers, which would either prevent the event from happening or may prevent the severity of the event on the consequence side. So this can strengthen your program in a big way. And the most important thing this thing BOTA analysis does is it gives you an opportunity to map your current state. If you're mapping the current state, then you may come up with n number of recommendations, but at least you know how do you look, how is your plant, what's your risk, are you able to, are you in a position to carry that for a long time, or what is it that you're required to do to ensure that if I'm having a risk at site, these are the few things that I should be doing to ensure that there's no loss of primary containment. One
Correct.
example could be you could be operating at lower capacities. Know that you're not having loss of containment. I know that I'm operating at this capacity, so I'm absolutely sure that I won't have any loss of containment.
Correct. So then, Amrish, then how can we check the mechanical integrity or the RLA of non-metallic storage vessels?
Yeah, see, as I spoke during the initial slides, when we initial slides when we were discussing about the structural integrity part of it, there is a whole bunch of methods available for doing DT and NDT. There are destructive testing mechanisms available. There are non-destructive testing mechanisms available. You can make good use of available practices wherein there are so many organizations who are providing necessary support to evaluate the structural strength of each of those assets. And you can inbuild that in your existing maintenance program with a lot of focus on the critical assets, wherein the asset integrity at least is not at loss during any point in time of operation of the life cycle of the unit.
Okay. And what is the life of these critical assets? Any specific lifespan that they have?
Yeah, I think that's a very relevant question, because if you look at the instrumentation assets, most of them would be having a lifetime of 10 years. The electrical assets may have life between 20 to 25 years, and the mechanical assets could be used beyond 30 years also. So I think it's necessary that you at least map down the lifetimes for critical assets. Especially the most important of the lot is the solenoid walls that you use. The solenoid walls could be very notorious. They can have lifetimes of less than 3 years to 5 years also. You be absolutely sure that some of these critical assets, the instrumentation stuff or the electrical stuff which is critical, it's replaced at the right time. Because if the bathtub event has to come in play, you will have a lot of failures at a particular point in time of the life of the plant, like from, let's say, 10 years to 15 years period, or 15 years to 20-year period. You'll have multiple failures that are happening, and that is because you have not embedded the concept of using the equipment within the useful lifetime of that equipment. You're using it beyond the lifetime, and that may deteriorate your maintenance program very badly, and it may also lead to a process safety even, unfortunately.
Correct. So, Amrish, this is my personal question to you since we're talking about maintenance. So, as you
Yeah.
said, talking about maintaining assets that have a long life cycle, let's say 25, 30 years. So, how important is regular maintenance on checking of these assets important? Like, how does it play a crucial role?
Yeah, see, There are two ways of looking at it. One is there's a recommendation from the OEM for all the critical assets which have this lengthier lifetime. You have to definitely follow the guidance that the OEM gives. But other than that, refer to the graphs that I shared with you. If you happen to see deterioration of the asset within the like if I have a preventive maintenance frequency established for a critical asset, and within the predefined frequency, I'm having more failures. I have to relook at the frequency of maintaining that asset. If I'm doing it at a frequency of 1 year, probably I may be required to do it at a frequency of 9 months or 6 months. If the failure is, it's happening more than often. So you have to
Okay.
relook at the frequencies. It could go beyond the suggestions that the OEM has given. And remember one thing very succinctly: the OEM frequencies are valid for the lifetime of the asset. Beyond the lifetime of the asset, there are practices which are there, which people generally follow. There's RBI, RCM. These are two different maintenance practices people follow to use the asset beyond its predefined lifetime. Having said that, use all available tools, but remember, you still have to define a cutoff date. Don't stop short of defining the cutoff date. A lot of guys are not interested in putting a equipment out of use.
Oh, very
Don't
true.
wait for it to fail and then put it out of use. Assume that it has failed. It's good to have an accident on a conference room table than experiencing it in a plant. Assume that there's a failure that has happened. See what could be the consequences on a table, and based on those consequences, make your decisions.
Correct. I think very true. I think all of us wait till the end for something to happen and then we
Yeah,
look into, so prevention is always better than cure. Yep. So thanks, Amrish. There are a lot of questions that are flowing in. I would request the audience, in case you have any further questions, to please write to us at marketing@bridgesafe.in. That's marketing @britsafe.in. And we'll make sure to address all of your questions. So thanks, Amresh, for this very informative session. And on behalf of the British Safety Council India, I would like to thank all of you that took time to attend today's webinar. And I'm sure the insights gained and all the questions answered has helped to improve the lives of many at large and has changed your perspectives about process safety management. So please remember to fill out this short survey form with your feedback that will appear on your screens shortly after this webinar has ended. Goodbye, thank you, and have a lovely day ahead. Thanks, Amrish, once again.
thank you.